Hello and welcome to the 4-1 Notes. This is a video on classifying triangles, and the first thing I want to do is talk about what a triangle is. A triangle is a three-sided figure, okay? And so, we've all seen triangles, we have a little bit of knowledge about triangles, but I want to talk about how we can name them and how we can classify them. The first way is by the angle measure, okay, so by angles, okay, and so we've got a few options here. We've got equiangular, okay, that's the first one, equiangular, and that's when all angles are congruent, okay, and we just know that those would all be 60 degrees, okay? We'll talk about that later. But if I were to draw a picture of an equiangular triangle, then I would say that all of my angles are congruent, okay? So that's the first one. The second one we would have is acute, all right? And acute triangles, that means that all angles are acute, okay? And so, I would maybe have something like this where I'd have, like, say this is 70 degrees, and this is, say, 60 degrees, and then, what would that be, 130, so then the last one would be 50 degrees, okay? All angles are acute, they're less than 90 degrees, okay? And then we would have obtuse angles, or an obtuse triangle, okay? And that's when one angle is obtuse, okay? And so that would be something that looks like this. Let's say you had a triangle where this is, say, 100 degrees. Let's say this is 60 degrees, and this angle here would be 20 degrees, okay? And then the last type of angle that we would have if we did it by, or last type of triangle that we would have if we measured it by angles would be a right triangle. And right triangles are some of my favorite triangles. And that means that you have one angle that is 90 degrees, okay? And so let's say I had an angle here, a triangle like this, and I would denote it as a right angle like that, okay? I would maybe call this, say, 40 degrees, and this is 50 degrees, okay? We'll spend a lot of time talking about right triangles, mainly because they're related to my friend, Pythagoras. So those are the four different kinds of triangles that we can name them by angles, okay? And then what I can do is I can name these angles by, or name these triangles by their sides, okay? And so if I wanted to talk about side lengths, and we would have, the first one is a scalene triangle, okay? And that's where no sides are congruent, okay? No sides are congruent. They're all different, all right? And so that would be, say, something like this, where, these are all different side lengths, okay? The next one that we have is a, let me do sides like that and box it in. We have a scalene, we have an isosceles, so isosceles, and that's when two sides are congruent, okay? And so then what we would have is something like this. A triangle with two sides are congruent. Okay, and we also know, something I'm going to share with you right now, is that in an isosceles triangle, the base angles are congruent. So I'm going to call these the base angles are congruent. Okay, and so then we have a third one. And that third one, we would call that an equilateral triangle. Okay, so an equilateral triangle. And that's when all sides are congruent. Okay, all sides are congruent. So if I were to draw something like that, it would look like this, and all the sides are congruent. Okay, also in an equilateral triangle, then we know that all my angles are congruent, and so all the angles would be 60 degrees. So I'm going to write all angles are congruent, and they are 60 degrees. Okay, so equilateral triangles are the same thing as equiangular triangles. And so those are the different types of triangles that we have. Okay, we have those types. So we can name them by their angles, or we can name them by their sides. All right. So let's just take a look here. On this, it says classify each triangle as acute, equiangular, obtuse, or right. And so we're considering these four options here. So when I look at number 1, okay, I notice that all of my angles are 60 degrees. They're all congruent. Okay, and I can come in here and draw those little symbols and show that, okay, but I'm going to call this equiangular. Okay, and then on number 2, all my angles are different, okay, but one of them is larger than 90 degrees. So this would be an obtuse triangle, okay, so this one is obtuse, okay. And then on number 3, one of my angles is 90 degrees. All right, so I would come in here and I'd draw my little symbol there. And so this is a right triangle. Okay. Let's take a look at number 4. Okay, all my angles are different, and they're all less than 90 degrees. So I would call this an acute triangle. All right. And then on number 5, I've got one that is, I've got one angle here that's over 90 degrees. This one's 100 degrees. So it has an acute or an obtuse angle. So this is an obtuse triangle. Okay. And then I would have, on number 6, this is actually an isosceles triangle. But because all of my angles are less than 90 degrees, this would be an acute triangle, okay? And it would also be isosceles, but it's not asking us for the side length name. So, okay. So let's take a look here at number 7 through 10. And this says classify each triangle as equiangular, isosceles, or scalene. Okay, and it gives us all these different names of triangles. And so how we would name it is we'd put the little triangle symbol and then the 3 vertices that it has. So on number 7, it says triangle ABE. So if I go over here and I look at triangle ABE, okay, and that's this triangle here, ABE, what I notice is that this side length is 9, okay, which is not the same distance as AE, okay? And then it has this other length of 8 times the square root of 2. So this would be a scalene triangle, okay? So on that one, I'm going to write scalene, okay? Let's take a look at triangle EBD. So if I came here and I look, EBD is this right here. What I notice is that this length and this length are congruent, okay? And it's not congruent to EB, okay? So ED and BD are congruent. So this would be an isosceles because I have 2 side lengths that are congruent. So this is isosceles, okay? And then if I look at triangle EBC, okay, and that's this triangle here, EBC, what I notice is that I have this side here, I have this side that's 8 times the square root of 2. These two are not the same length. And then this length is double that other length. So what I know is that these aren't congruent, okay? Or not all the sides are congruent. They're all different. So because of that, I'm going to call this a scalene, okay? A scalene triangle. And then I've got triangle DBC, and that's got all of those sides are congruent. Okay, so I'm going to call that an equilateral triangle. Okay, equilateral. Okay, all right, so now let's take a look. And it wants us to know, okay, in number 11, and this is the algebra portion of it, it says find the value of x and the length of each side if ABC is an isosceles triangle where AB is congruent to BC, okay? So here's what I've got. We're assuming, and it's not, the picture doesn't show it, but we're just going based off of the, of what it's saying, that it's an isosceles. So I know that these two segments are congruent, those two lengths. So that allows me to set up an equation and solve for x. And so I would write the equation here, 4x minus 3. Okay, I'd say 4x minus 3 is equal to 2x plus 5. Okay, and so what I could do is I could solve for x. I'm going to subtract both sides by 2x, combine my like terms. And so I get 2x minus 3 is equal to 5. So then I could add 3 to both sides, and then I get 2x is equal to 8. And then divide everything by 2 and by 2, so x is equal to 4. Okay, so if x is equal to 4, okay, and it wants me to find all the other lengths, okay, of this triangle. So the first length that I would write would be AB. So the length of AB would be 4 times 4 minus 3. So AB would be 16 minus 3, which is 13, okay? So if AB is 13, that also means that BC has to be 13. But let's go ahead and write that in, that BC would be 2x plus 5. And let's substitute in 4 for that. So BC would be 2 times, here, let me erase that real quick. That would be 2 times 4, okay, plus 5. And so BC, that would be, okay, that's 8 plus 5 is 13, so it's also 13, okay? And then AC, okay, the third side would be x plus 2, which in x is 4, so it would be 4 plus 2. So AC would be equal to 6, okay? So pretty self-explanatory stuff. We just got to, use what it says, and where it says an isosceles triangle, okay, and know the properties of that and be able to draw a picture, okay? So kind of the same stuff we've been doing, just building on what we know, okay? And so then, okay, on this one, it says find the length of each side of triangle FGH if triangle FGH is an equilateral triangle. So if it's equilateral, I know that all of my sides are congruent, okay? And so I can set up an equation with any of these, okay? And so what I'm going to do is I'm just going to pick FH and GH, okay? And so I'm going to write the equation 5x minus 8 is equal to 4x plus 1. And so if I subtract 4x from both sides, then I get x minus 8 is equal to 1. Okay, if I add 8 to both sides, then I end up getting that x is equal to 9. Okay, and so what I want to do is I want to plug this value in and see what we get. And I'm just going to go ahead and plug it into FH. That one seems the easiest to me. And so if I found FH, okay, then I would, let me erase that, make that look a little bit nicer. Okay, FH is equal to 4 times 9 plus 1. Okay, so FH is equal to, say, 36 plus 1, so that gives us that FH is equal to 37, okay? And so if FH is 37, then I know that GF is equal to 37, okay? And then I also know that GH is equal to 37, okay? I mean, you could plug, 9 in for X into all of those, but if you know that they're all congruent, then you don't need to do that, okay? So I hope that was helpful for you. I really enjoy this, and I'm really excited to embark on the adventure that we call triangles. So I hope you enjoyed this video. I had a lot of fun making it, and we will see you soon. Thanks. Bye.